Assalamu alaikum wa rahmatullah wa barakatuh. Now I will solve with you the last two examples on chapter 4 on section 4.4. Here, question number 30, solution. Question number 30. Suppose that we have two events, A and B. Probability of A equal 0.5 and probability of B equal 0.6 and the probability of A intersection B equal 0.4. A. Find the probability A given B. You must write the formula, which is probability of A intersection B divided by probability of B, which is 0.4 divided by 0.6, which is 4/6, 2/3. Number B, probability of B given A, which is the probability of A intersection B divided by probability of A, 0.4 divided by 0.5, which is 4/5. Notice that probability of A given B not equal to probability B given A, which I mentioned for it when we discuss section 4.4. Number C, are A and B independent? Why or why not? In order to test for independence, you must check the following. One, probability of A given B. See if it is equal to probability of A, or 2, probability of B given A. See if it is equal to probability of B, or number 3, calculate probability of A intersection B. See if it is equal to probability A multiplied by probability of B. You can check one of them, but I will check it for you, all of them, in order to convince you that they are all of them the same, has the same answer. Probability of A given B, which is how much? 2/3. What is the relation with the probability of A? 0.5, which is not equal. Here again, probability of B given A, which is 0.8. What is the relation with the probability of B? 0.6. It is not equal. Here, probability of A intersection B, 0.4. What is the relation with probability of A? How much? 0.5 multiplied by probability of B, 0.6, which is 0.3. Also, it is not equal. From 1 and 2 and 3, A and B are not independent, or they are dependent. We finish question number 30. We will move now to question number 33. But before we move, we will see the number of the page, which is 197. 197. Here, page number 197. Solution. Question number 33, page 197. Here I will read, first of all, I will read the question. Students taking the graduate management admission test GMAT were asked about their undergraduate major and intend to pursue their MBA as a full-time or part-time student. A summary of their responses followed: undergraduate major, and here intended full-time, here business, engineering, and other two totals, and here enrollment, part-time, status, totals. Develop a joint probability table for these data. Before I will return to see the original question, here undergraduate major and intended enrollment status. Before you will begin, you must define a new event. You cannot write the word business in the table, joint probability table. You must use events that shows probability. These are not the probability, these are numbers. But in order to find or develop a joint probability, you must here write the probabilities inside it. Here you have business, engineering, and others. Let or define business, define A as a business measure, business measure, and B as engineering measure, C as other measures. Now, enrollment, here part-time, I will return to see the here full-time or part-time. Full-time, part-time, you will have it here. Define D as a full-time, and D complement as a part-time full-time D define it, and part-time D complement. You will say to me, why you didn't put A and A complement? You can put A and A complement if I have two majors, business and engineering, suppose. But here you have three majors. This is why I cannot put complement. Here C D equal, and here D, but I will write it in another color, D complement, to be obvious. Here I will begin to construct the table, but before we make construction, or we can calculate it here. Enrollment, undergraduate major enrollment time, here enrollment, time, and measure. Here I will write measure. Here we have A, B, C, and total. Down here on the left I will put D and D complement and total. Here, in order to calculate the probabilities, here we will have 300. Wait a minute. No, I have here total 1,305. Here, these are totals. 352. 52 divided by 1,035, and the other 197 divided by 1,305, the others 251 divided by 1,305, the total 800 divided by 1,305, also 150 divided by 1,305, 161 divided by 1,305, and 194 divided by 1305, 505 divided by 1305. Here you will have 1. Here the total 502, 502, 502 divided by 1305, and here you will have how much? 358. 358 divided by 1305, and the other will be 445. 445 divided by 1305. I will calculate it for you. Here, calculator. You will have 352 divided by 1305 equal point 0.2697. I like to take the first 4 decimal after approximation. Here 197 divided by 1305, which is 0.15 or 1, since 5 is the approximated to 9 to be a 1. Also we have 251 divided by 1305. It will be 0.1923. 800 divided by 1305, it will be 0.6130. Also 505 divided by 1305, it will be 0.386 or 70. Here 194 divided by 130, 305, it will be 0.1487. Here 161 divided by 1305, it will be 0.1234. And 150 divided by 1305 equal here 0.1149. Here the last 3 numbers, 502 divided by 1305, it will be equal to 0.3847. And here 358 divided by 1305 equal 0.2743. Here 161 divided by 1305, it will be and 358 58 divided by 1305 3 and also 445 divided by 1305 equal 0.341. Here you will have approximately similar, but 352 divided by 1305, it will be 26. Since I make approximation, it must be the same. Here 150 divided by 1305, it will be 4 approximately. Here you will have this table is called, this table is called joint probability table, joint probability table for the data. Use the marginal probabilities of undergraduate major business engineering or other to comment on which undergraduate major produced the most potential MBA. This is A. B, a probability of A, which is 0.3847, probability of A equal 0.3847, probability of B equal 0.2743, probability of C equal 0.341. Here the most margin كده here the most greatest marginal probability will be probability of A, which is of business major, which is of business major, and it measure produce the most potential MBA, produces the most potential potential here the word I will write it, the most potential is wrong, I will erase it. Shell, the most potential MBA. Here I finish part B. C. If a student intends to attend the classes full time in pursuit of an MBA. Number C, full time probability. I will erase it, sorry. Probability of he wants to attend full time, yes, which is D. I define it as a D event. If the student intends to attend classes full time in pursuit of an MBA degree, what is the probability that the student was an undergraduate engineering major? Engineering major is B. B, what is the probability? What is the probability that the student has an engineering major if or given that he is a full-time, which is the probability of B intersection D divided by probability of D. I will see from return back to joint probability table B intersection D, which is 0.151 over probability of D. Probability of D here, D 0.6130. I will calculate it. Point 150 divided by 0.6130. It will be 0.24633. Part D. Part D in the question, he says, if a student was an undergraduate business major, probability of given B. Sorry here, students. I here didn't see the undergraduate engineering, yes, B, engineering B, but here in question D, sorry for disturbance, if a student has undergraduate business, which means A. Here, given A, I return back here to the definition that I put it, that A is business. E, if a student was an undergraduate business major, what is the probability that the student intends to attend class full-time in pursuit of an MBA degree? Full time, I define it here as D. Full time as D. Then write always the formula probability of A intersection B and A intersection D. I always say that probability A intersection D the same as probability D intersection A over probability of A. Go to the joint probability table. A intersection D. A intersection D, which is 0.2697. 0.2697 over 97 over probability A. Probability of A, this 0.3434 3847. 0.3847. Check it again in order. Here probability of A 0.3847 and probability of A intercept 0.2697. I will calculate it. You will have 0.2697 divided by 0.3847 equal 0.7011. CDE. Completing the question, we finish part D. E. Let A donate the event that a student intends to attend the class full time, which is D, in purchase of an MBA degree. And B, donate the event that a student was in an undergraduate business major. I will not follow these symbols since I make for me another symbol, A for business and D for full time. Then are events A and B independent? Justify your answer. Are A for business, and D for full time. Are A and D are independent? Are A and D are independent? In order to test solution, C probability D given A, is it equal to probability probability D, sorry. Here you will have for a solution 0.7011 and probability of D from the joint probability 0.6130, 0.6130, which is not equal. But you can make another test. Here, this is 1. Or probability of D intersection A. Is it equal to probability of D multiplied by probability of A? But don't do it. You need to test one, only one. If it is not correct, it is not independent or dependent. But I show you many ways in order to choose. Here, probability D intersection A. How much from the joint? Which is 0.2697. 0.2 697. Probability D alone, 0.613. 0.613 multiplied by probability A alone, 0.3847. 0.3847. 0.3847. I will make multiplication in order to convince you that it is not independent. 0.6130 multiplied by 0.3847. Here 0.2697. What is the relation with 0.2358? It is obvious that they are not equal. From 1, this is 2. From 1 or 2, we notice that A and D are not independent. In other words, full time is dependent from business measure, or what? Business measure. I will stop this video in order, since it is approximately 39 minutes, and I will begin chapter 5 inshallah in the next video. Thank you very much, and see you inshallah next chapter.